I am Dr. Singh. I am working as an assistant professor of mathematics at ABES Engineering College, Ghaziabad. My today topic is maxima and minima of function of two variables. These are some contents. First of all, we give the introduction of maximum and minima. Then we give some formal definitions. After that, the working rule of maxima and minima. Then we give examples. So first of all, discuss what is maxima and minima. So a function fxy is said to have a maximum value at point x equals to a and y equals to b if f of ab is greater than f of a plus h and b plus k for small and independent values of h and k, which is either positive or negative. Similarly, a function fxy is said to have a minimum value at x equals to a and y equals to b if f of ab is less than f a plus h and b plus k for small and independent values of h and k, which is either positive or negative. So fxy has a maximum or minimum value at a point ab if f a plus h b plus k minus f ab either less than 0 or greater than 0. Now, what is stationary point? The point at which the function is either maximum or minimum is known as stationary point. And the extreme value, the values of the function at a stationary point is known as extreme values of the function fxy. Now, we discuss the working rule of maxima and minima. So, to determine the maxima and minima of a function, first of all, we solve del f over del x equals to 0 and del f over del y equals to 0 for different values of x and y to get a point which is called the stationary point. After that, we obtain the value of r, s, and t. Then we calculate rt minus s square if rt minus s square is greater than 0 and r is less than 0 at point AB. Then fxy is maximum at that point and maximum value of the function is f of AB. If rt minus s square is greater than 0 and r is greater than 0 at point AB, then fxy is minimum at that point. And the minimum value of the function is f of AB. If rt minus s square is less than 0 at point AB, then fxy is neither maximum or nor minimum at the point AB. Such point is called the saddle point. Now, if rt minus s square equals to 0 at point AB, then no conclusion can be made. So further investigation is required. Now we take one example. So the question is discuss the maxima and minima of the function. So this is a function. So let fxy equals to x square plus y square plus 6x plus 12. Now we calculate the first order partial derivative del f over del x, which is 2x plus 6, and del f over del y, which is 2y. Similarly, we find the second order partial derivative r, which is del square f over del x square, which is 2, and calculate s, which is del square f over del x del y, and this is 0 because we differentiate y with respect to x, so 2y is constant, so equals to 0. Again, we calculate t, which is del square f over del y square. So it is 2. Now, For stationary point, we put del f over del x equals to 0 and del f over del y equals to 0. This implies 2x plus 6 equals to 0 and y equals to 0. So we get x equals to minus 3 and y equals to 0. So we get a stationary point P, which is minus 3 and 0. Now we check this point for maxima or minima. For this, we calculate RT minus S square. So R is 2 and T is 2 and S is 0. So it is 4, which is greater than 0. Also, R is 2, which is greater than 0 at point minus 3 and 0. So this point is the point of minima. This is point of minima. Now we find the minimum value of function. The minimum value of function. Now we put x equals to minus 3 and y equals to 0. Then the value of the function at the point minus 3, 0 equals to, this is x square plus y square plus 6x plus 12, which is 3. So this is the minimum value of a function at the point minus 3, 0. Now we take another example. Find the extreme values of the function x cube plus y cube minus 3a xy. So let fxy equals to x cube plus y cube minus 3a xy. Now we find del f over del x, which is 3x square minus 3ay, and del f over del y, which is 3y square minus 3ax. Also we find the second order partial derivative del square f over del x square, which is 6x. Similarly, as del square f over del x del y, which is minus 3a, and t equals to del square f over del y, which is 6, 5. Now for a stationary point, we put del f over del x equals to 0 and del f over del y equals to 0. So we get two equations. One is x square minus ay equals to 0. This is equation 1. And second is y square minus 3a, sorry, y square minus ax equals to 0. This is equation number 2. So from 1, y equals to x square equals to a, we put in equation number 2. So we get x to the power 4 minus a square x equals to 0. So this implies x to the power 4 minus a cube x equals to 0. This implies x cube minus a cube equals to 0. So we get x equals to 0 and x equals to a. So if x 0, then y also 0. If x equals to a, then y also a. So we get 2 points. First 0, 0, and second one is A, comma A. These are two stationary points. Now we calculate RT minus S square, which is 36xy minus 9a square. So at 0, 0, the RT minus S square equals to minus 9a square, which is less than 0. So no extreme value, that is, it is a saddle point. Again, at point A, comma A, we get RT minus S square equals to 36a square minus 9a square, which is 27a square, which is always positive for different values of A. Now we check R. So R is 6a. Now there are two possibilities. First, if A is greater than 0, then R is also greater than 0. So AA is the point of minimum. And the minimum value of function is minimum value of function is AQ plus AQ. We put x equals to A and y equals to A in fxy. So we get AQ plus AQ minus 3AQ, which is minus AQ. This is the minimum value of the function. Now, if A is less than 0, then R is also less than 0. So AA is the point of maximum. And the maximum value of function is, now we put x equals to minus A, y equals to minus A, and this equals to A. So this is the maximum value of the function. So today we discuss the first part of maxima and minima of the two variable. Now in next video, we take some application part of maxima and minima. These are some references. Thank you so much.